Thank you very much. I'm very happy to be here in Seoul, so good morning to you all. And I think Doug explained this just now. Just make sure we got translation. I try to speak slowly. If you want to listen in English, that's fine. Otherwise, use the translation, and we will have it live translated. So I'm very lucky that I actually am allowed to travel all across of Asia Pacific and look at some of these emerging or new technologies. And today I wanted to share with you some of the things that I've seen and some of the things on how it will affect us as developers. Now I want to start with saying thank you to you all. Thank you because you are developers and you are the pioneers of cloud innovation. In 2006, Amazon Web Services, AWS, started off with two services, Amazon S3 and Amazon SQS, a storage service, highly available, highly scalable, and a highly available and scalable queuing service. That's what we started off. Developers liked it. They used it to put images to their S3 bucket, and they could enhance their websites with it. It became so popular to actually have access via an API to services like S3 and SQS, to a point that we extended this functionality and capabilities to what you wanted, to what you have asked us. So you have helped to pioneer that cloud innovation to where we have become now. AWS, Amazon Web Services, and all these new interesting technologies and services that we are making available for you and I want to show you today. Now, having said that, a lot of these recent advancements in AI, IoT, big data, all of these things are due to the increasing speed on how we develop software. And the way we develop software was waterfall model, traditional, slow. But nowadays, we accept a very fast pace of developing pieces of software. We probably all in this room develop lean, use lean software development principles, small team, quick iterations, deliver as fast as you can, try it out, measure your success. If it's good, continue. Not good, improve on it, find the problems. You eliminate the waste of making wrong choices by quickly trying things out. And obviously, one of the things that helps you here is cloud computing. Having the ability to tap onto a service, pay for it on a per second or per volume basis, and experiment around, see if something works. If it doesn't work, then we remove it, we bring it back. And this is how we develop software. But how do we deliver software? Well, traditionally, we used physical hardware, right? We had servers, we put them somewhere in a data center, we built them out, we deployed our software. Then we decided, okay, how about virtualizing servers? We looked at a hypervisor, we built virtual servers. Hey, there's this cloud computing thing. I can now get servers on demand at any point in time with a click of a button. Great. Then we came up with another great idea as developers. How about containers? If you're developers like me, then I would always develop my piece of software in my laptop, I'd try it out, and then traditionally I pushed it out to the server, right? Run it on the server, something breaks, the infrastructure guy comes back to me and say, your code is wrong. I say, no, my code is correct. Your server is wrong. You don't deploy correctly. Worked on my laptop, right? Containers removed that problem. Whatever works on my laptop will work on that server because we package the operating system dependencies and the libraries all in and deploy it out. So that's fantastic for us as developers. Removes a lot of headache of making things work. And now moving forward, we will move more and more into a function-driven space. So if you're familiar with projects like Kubernetes, which allows us to run containers, they now have extensions like Fission that allow us to even have this function-based programming models on top of container scheduling software. We further make that more interesting in actually delivering services that allow you to only develop your functions, that one function that solves one specific problem within your application. And it only triggers that piece of code when that function actually needs to be triggered. We call it serverless. Develop your code without thinking about servers. One of these services that we offer is AWS Lambda. Allows you to run your piece of code fully managed at any scale, but you only pay for the execution time of your code. How many milliseconds did your code run? And that's what we pay for. That's great for experimentation. But it's also changing the way we think about developing software. Instead of having one big deployment piece, we now have many small individual functions that all serve their one purpose. And that allows us to build what we call event-driven architectures. React only when something happens, and only react upon that one event. Now, we do have some tools that can help you use these models. We call it SAM, this little guy here. It's the Serverless Application Model. And the Serverless Application Model allows you to develop your function here on your laptop and then easily click a button, say, push it out, and now it scales to millions of people. But only if those millions of people are using it. And we recently also launched the functionality to locally, on the machine itself, with the help of SAM local, to actually test the function completely locally. When we're good to go, we push it out, including the event-driven architectures. It's open source, so you can freely use it, you can freely change it, modify it, and repurpose it. Talking about open source, I think open source is great. I love open source. Because if you're a developer like me, it's all about openness. You write some piece of code, something breaks, what are you going to do? Copy, paste into the search engine, first search result comes out, Stack Overflow, somebody with the same problem. I solve it like this. Select, copy, paste, done. I programmed. Openness is great because it allows us all in this room to collaborate when we want to collaborate. But it also allows to improve adoption of products that you're using. Not only the product that you, or the piece of software that you're developing, but also the product itself. If we embrace an openness to an entire ecosystem of different platforms, we can make a product more successful. I want to give you an example of this. What you see here is a device called the Amazon Echo. And the Amazon Echo is one of the devices that you can use to talk to what we call the Alexa voice services. The Alexa voice services allow you to use your natural language and speech to interact with a system. Now you're going to say, all right, just a smart assistant, right? There are many out there. There's Siri, there's Bixby, Google Home, etc. That's not what I want to show you today. What I want to show you today is, this is a perfect example of a product that becomes popular due to its openness. Let's just have an understanding on how it works. I brought an Echo Dot with me, which is the smaller version of the Echo. And the way it works, it listens to a wake word. The default is Alexa. And if I say that wake word, it will listen to me and it will respond to me. If you like to watch Star Trek, or you're a Star Trek fan, you can change the wake word from Alexa to computer. All right, so you watch Star Trek. Computer, do this, do that. Awesome. Let's try this out. Alexa, say hello.
Hi.
Alexa, how are you today?
To be honest, it's been kind of a rough day. Just kidding. I'm great.
Good. She's changing this response magically sometimes when she talks to me. Alexa, where are you right now?
I'm here and my head is in the cloud.
Ah, her head is in the cloud. And that's a good thing, because it allows us to extend the capabilities of what we can do with those voice services. The reason I choose this as an example of openness is it doesn't matter which speaker you're using. Here I'm using an Echo, but you can actually use these voice services in any hardware you produce. But more importantly, you as a developer can extend the capabilities of what she's able to do. We call it skills. So for example, I can book a taxi on Uber, for example, via my voice. I can order a pizza via my voice. I can order a coffee via my voice. I can stand in the kitchen cooking something, ask her via my voice of a cooking recipe of a platform that you might be developing. How easy is it to actually extend these capabilities? It's pretty straightforward. You create a so-called skill. That skill talks to your code, and that code can be on your platform, on your website, on a server, or if you want to do it serverless, which is my recommendation, use AWS Lambda. Now, what can we do with this? Well, if other platforms are open, like Facebook has an API, then I can actually use this openness to put things together. So let's take an example. What if I create a Facebook page and I actually want to ask my voice services to read out new Facebook posts? How would that work? Let's have a look. There we go. Time to show some code. This is developer day after all. So the first thing that we need is obviously a Facebook page. Now I did create a Facebook page and I called it the webhook demo page, and is also available for you. The next thing that we want to do is we actually need to have the ability to talk to the API of Facebook. For this, we can go to developers.facebook.com, and from there we can create an application, which is what I did here. I created a Lambda demo application. I can tie that back to my page, and then I can use what is called webhooks. The ability to be notified whenever something happens. And if you look closely here, I actually subscribed to the feed of my page. And whenever that happens, Facebook will talk to my Lambda function. My Lambda function can store the post. Now the next thing that I can do is I can create an Alexa skill. And that Alexa skill can read out...
I'm not quite sure how to help you with that.
Can read out that piece of information when I ask her to do so. So let's have a quick look at that. I can create an AWS Lambda function, and I can then tie it back to an Alexa skill. Here we go. Here's my Alexa skill Facebook page function. I do a few things here. I use the Alexa skill SDK to quickly build a skill, and I create two intents. One to ask for new Facebook posts, and one to ask how many Facebook posts we have. And then I use this information that I have stored in my DynamoDB table back from my webhook. How do I put it all together? As I mentioned, AWS Lambda can be event-driven. Do something when something happens. And one of those triggers can be, for example, the Alexa skills kit. So I can tie it back up with a trigger here that is enabled, and now I have the ability to enable the skill on my voice services and use it to read out posts. Let's try this out. Let's post something on the page here. Let's say, hey Saul, great to be here. Always like to show some code since we are developers. Whoops. Developers. Probably should type that correctly. There you go. So the next thing that happens if I hit this post button is being sent to Facebook. Facebook will then, let me just refresh the page to make sure it's there, will then notify my webhook. My webhook will store it in my AWS environment, and then I should be able to ask my voice services to read this out. Alexa, ask Lambda bot about new Facebook posts.
Olivier Klein was writing, "Hey Soul, great to be here. Always like to show some code, since we are developers."
Awesome. So very easy to integrate things together. Few lines of code, few Lambda functions magically glued together, and we now have an ability to use my voice to expand capabilities, talk to other ecosystems such as Facebook. Openness helps us as developers to create successful products. Openness allows us to extend capabilities. And we truly believe that within Amazon. Actually, just recently, we announced that the Alexa voice services will also support Cortana. If you don't know Cortana, Cortana is Microsoft's voice assistant. Similarly, Cortana will also support the Alexa voice services. Why? Cortana is really good to connect with your Office 365. Really good at knowing your calendar in your Office 365. Alexa is really good for developers to integrate against their platform. This openness creates new ways of being successful. I encourage you as a developer to think how you can make your products open to build a great ecosystem. Now, what it brings me to is more and more devices will connect. This is a perfect example of IoT, a device that talks to a cloud environment, renders a voice, maybe talks to another platform, then talks back to me. More and more devices will connect. Pretty much everyone probably has one of these in their pockets, phones, more and more APIs and openness around it, which will allow us to collect more and more information, more and more data, understand the physical world better with sensors, for example. And we will start processing that data fast to a point where we process it in real time to give us insight into our business, understand our customers. And as we start processing that faster and collecting more data, we can think about using machine learning, and specifically deep learning machine models, to build intelligence around the data. Artificial intelligence, AI. So what does that mean? We got to start off first with the ability to actually connect devices. It's of utmost importance that we make sure that whatever we develop and where we connect things together, that security is our number one priority. Within AWS, security is job zero, the first thing that matters. No security, no business. If you build IoT solutions, have security in mind. We have services that can make it easy for you. This afternoon, if you're interested in more detail, we have Andy who presents a session about AWS IoT. Service that can make it very easy to securely connect billions of devices. But as you develop, also keep the security of the device in mind. Now, that brings us to the point of having more and more devices collect data, more and more devices talking to our applications. And not only our devices, but other people's devices, other ecosystems. So we'll have more and more information coming through. So as a developer, I need to choose the right model. And the right model for more and more data is not to listen to everything. It's to listen to specifically only what I want to know. Only specifically react to what we need to react to. Remember serverless? Remember AWS Lambda? React when something happens. When we talk IoT, the same thing. Apply a publish-subscribe strategy. Publish onto a channel, other people can listen. Subscribe to only what you want to listen to. All right, enough of talk. I think it's time to have some fun with a demo, and I'm just going to invite Andy also on stage, who will help me with some of the things here on stage. So I brought with me toys, since I'm emerging technologies, so I get to play with toys. And so we can just switch over to the camera. I think Andy can then help me to show you what we're going to do. I brought with me, and if you can just have a go at the devices here. Perfect. So I brought with me a few things. The first thing here, I brought with me a Sphero robot. So this is like a small little ball here, and I can use this ball to basically roll around. And this is the Sphero SPRK Plus model. You might have heard of the BB-8 model, which is a similar Star Wars kind of model of this company. I also brought with me a Raspberry Pi, and I use this Raspberry Pi to talk to the Sphero, because it actually has Bluetooth. It's the Model 3 of Raspberry Pi, so we can talk to the Sphero. I already mentioned the Echo Dot, and the Alexa voice services that we have with it. And I obviously also have a MacBook here with me. And we're going to use that MacBook actually as a voice output for this robot. So what I want to do is, how could I connect this robot to my cloud environment using AWS IoT, and then give it a voice, use the Alexa voice services to talk to it. And then in the next step, I'm going to use a virtual world through our Amazon Lambda Yacht game engine. And I will navigate a virtual robot, and I want the physical robot to react upon it. So let's try this out. Close Facebook here. And opening up my terminal. And what you see here, I'm just going to make this a little bit bigger. So, wrong window. Here we go. What you see here is basically the Raspberry Pi. I'm logged into this Raspberry Pi, and what I can do now is I have certain pieces of code. I have a Node.js drive piece of code, and this drive piece of code will allow me to power up that robot. Let's have a quick look at that drive.js here. So we're going to use a really cool open source SDK. It's called Silent SDK. And with that, we can talk to our robot. And as we talk to that robot, we want to connect it to AWS IoT. For this, we're going to use the AWS IoT device SDK. So as I now power up that robot, see that here, I can power up that robot. Here's my Bluetooth low energy identifier of that robot. I can start connecting this to this robot, and also connect this robot to AWS IoT. Now, if I do that, I can send certain messages back and forth through AWS IoT, and I can listen to that in my browser here. And at the same time, I can then play audio files on my MacBook. So whenever I would roll my robot, I play certain messages. Or if I speed up, I play certain messages because I'm listening to this topic. All right, let's try this out. Just going to...
Olivia, let me explain.
Please. Yeah.
잠깐 환경을 조금 설명을 드릴게요. 아까 에코랑 여기 스페로라는 로봇이 있고, 그다음에 라즈베리 파이가 있고 랩탑이 있습니다. 근데 아마존 웹 서비스에서는 AWS IoT라는 플랫폼이 있어요. 그러니까 IoT 서비스를 만들기 위한 플랫폼이 구성되어 있고, 여기에는 라즈베리 파이와 랩탑이 IoT의 서비스의 하나의 디바이스로 연결이 되어 있습니다. 그래서 라즈베리 파이는 이 로봇하고 블루투스로 연결이 되어 있어서 랩탑이나 라즈베리 파이를 이용해가지고 로봇을 컨트롤하거나 또는 어떤 변화가 생겼을 때 랩탑에서 사운드 같은 걸 재생할 수 있는 것들을 실시간으로 라이브 데모를 보여드리도록 하겠습니다.
Thank you. So what I will do now is I will actually power up my robot. And then let's get him on the camera here. You can just follow me with the camera. This guy should power up. Do we have enough power now here? Obviously, for a perfect live demo, things are bound to fail. try this one more time. Lots of Bluetooth noise in this room.
지금 라즈베리 파이에 로그인해서 라즈베리 파이에서 환경에서 실행을 하는 거고요.
My Raspberry Pi just died on me. That's okay. It wouldn't be a live demo if we don't have some problems. Just bear with me. Hello, Raspberry Pi.
조금 수줍음을 타는 것 같아요.
Let's just kill this guy off here. We have already a process running. Yeah, then it doesn't work. All right, let's do that properly here. There we go. Kill this all off and start fresh. There we go.
실행하려던 프로그램이 이미 돌고 있어가지고 약간 충돌이 있었던 것 같고요. 다시 시작을 하겠습니다.
All right. Hello. Hello, robot. How are you? All right. Now, I do have an audio output on my MacBook. So what I can do now is I can send messages back and forth between the robot, my Raspberry Pi, and if you look closely here on the side, also my AWS IoT console. So for example, I can change its language. I'm from Hong Kong, so it can also speak Cantonese. And by the way, also a bit of Chinese. And yeah, of course, Korean. There you go. Hello, robot. So what I can now do is I can send roll commands to that robot. And then we see that robot basically roll around. And we see this JSON strings coming through onto the robot. Let's speed this up. There you go. And our robot also has collision detection. So if I give it a little kick, it detects a collision and plays an audio file. Now, since we brought these things together, what I can do next is I can use my voice services to talk to the robot. Let's try that out.
지금 방금 보신 거는 제가 아까 설명드린 것처럼 라즈베리 파이하고 랩탑이 하나의 IoT 디바이스처럼 서비스에 연결이 되어 있어요. 그래서 랩탑에서 어떤 명령을 주게 되면 IoT 서비스로 메시지가 가고 그 서비스에 이제 펍스업 기능이 있기 때문에 거기에 이제 서브스크라이브 되어 있는 라즈베리 파이가 그 메시지를 얻는 거죠. 그래서 커맨드를 받아가지고 그 커맨드를 받자마자 이 로봇을 컨트롤해서 이렇게 움직인 겁니다.
Awesome. Back to Korean. There you go. Okay. Alexa, ask Sphero to change color to green. Now she will update.
I changed Sphero's color to green.
I'm not sure if it's very visible on the camera. Let's try with another color. Alexa, ask Sphero to change color to blue. There you go.
Sphero's
changed its color to blue. Alexa, ask Sphero to perform a stunt. Now we see the stunt come through, and my Sphero starts rolling around. So by connecting it to AWS IoT, I can remotely control, I can create a voice, which is what you hear, and I can use my voice to control.
방금 좀 전에 아까 이 로봇을 움직였을 때는 랩탑에서 컨트롤을 했었잖아요. 근데 지금은 알렉사 스킬킷을 이용해서 보이스로 명령을 주고 알렉사가 그걸 받아서 뒤에서 이제 람다 펑션이 돌아갑니다. 그럼 람다 펑션이 또 IoT 서비스를 이용해서 그 명령을 주는 거죠. 아, 색깔을 바꿨으면 좋겠다 라고 하면 당연히 거기에 지금 서브스크라이브 등록되어 있는 라즈베리 파이가 색깔이 바뀌는 명령을 받아와서 여기에다 색깔을 바꾸는 명령을 주게 됩니다.
Alexa, stop.
기분이 좋았나 봐요.
I have her play some Korean pop earlier. There we go. Now the next thing, apologies for that. The next thing I can do is I can create a virtual world. We have an engine called Aws Lambda Yacht, and I actually run that engine in an Amazon workspace. Amazon workspace is a virtual desktop in my cloud environment. So I'm going to launch that now here to access a 3D game editor here.
아마존 웹 서비스에는 워크스페이스라는 서비스가 있어요. 버추얼 데스크탑입니다. 그래서 랩탑에 윈도우나 뭐 이제 리눅스 환경 같은 게 있잖아요. 근데 이거는 아마존 웹 서비스 위에서 운영 체제가 있고 거기에 이제 윈도우즈 환경을 리모트로 접속을 해서 거기에 이런 럼버야드라는 게임 개발 환경이 설치되어 있는 화면을 지금 리모트에서 당겨서 보신다고 이해를 하시면 돼요.
So what I can do in that game editor is obviously do visual editing, right? So the usual thing of, I don't know, let's make this thing bigger here, etc. So a great way to edit a virtual world. What I can then start doing is I can start playing that game and control that robot around, for example. A Yacht is a nice engine. It has a particle engine, so we can do things like nice fire here, or here we can go to the forest and we see the forest come through. And obviously I have this world connected to the Alexa voice services. Let's try that out. Alexa, ask Yacht to say hello.
Hipster says hello.
Our hipster says hello. Awesome. Alexa, ask Yacht to make it snow.
We
Boom.
made it snow.
There we go. Now we have this virtual world connected with our voice services. The last thing, how do we connect this virtual world with the robot?
지금 보시면 버추얼 데스크탑 환경에서 럼버야드라는 그 게임 개발 툴이 돌아가고 있고 거기서 게임 데모가 하나 돌아가고 있어요. 근데 이 게임 데모하는 이 시나리오, 이 소스 코드 안에는 아마존 웹 서비스에 있는 하나의 심플 큐 서비스라는 메시지를 주고받을 수 있는 서비스에서 데이터를 읽어오는 걸 갖다가 코드로 들어가 있거든요. 그럼 알렉사에서 보이스로 명령을 주면 거기에 원하는 메시지를 그 큐 서비스로 넘겨주게 되는
In
거고요.
Seattle, it's 13
그다음에
degrees with
이
mostly
럼버야드라는
cloudy
거는 그
skies.
새로운 메시지를 받아서 아 내가 눈이 내리는 명령을 받았구나 라면 여기서 화면에서 눈이 내리게 하고 그다음에 이 로봇이 움직이는 명령을 받으면 로봇이 움직이는 것들을 화면에서 보여주게 되어 있습니다. 그래서 이 개발 환경 자체가 IoT 서비스랑 연결이 되어 있고 알렉사 보이스 키트하고 또 연결이 되어 있다고 보시면 됩니다.
I need to train her to only listen to me. Now what we can do now is I can connect this virtual world with my robot, and the way I do it, I use AWS Lambda. Every second I set the position, X, Y, Z coordinates, and I send it to the Lambda function, talk to the AWS IoT, Raspberry Pi, send it to the robot. Let's try this out.
멤버야 연결되었습니다.
Done. All right. Now what's going to happen next is we should have, if my robot didn't fall asleep here, which he did, there you go. Next thing that happens is, if I now start navigating this robot in the virtual world around, just
그래서 지금 랩탑으로 컨트롤하고 있고요. 그 메시지가 IoT 서비스로 전달되고
if I put this
가상
around,
환경으로 지금 전달되고
we
있습니다.
see that the robot in the physical world will actually react now onto the movements that we're doing of the robot itself. There you go. Let's go a bit more to that side. More to that side. And we got stuck. Got stuck.
도움 필요할 것 같아요.
And now we connected this virtual world together with the physical world. And if we look at the output here, you see that we continuously get commands through that tell us where we need to roll and in which direction we need to roll from that virtual world.
멤버야 연결 해제되었습니다.
Awesome. Thank you, Andy. And I close my workspace here. There you go. So a perfect example of, let me bring her back first here. There you go. A perfect example of how we take certain things, use a connecting service, IoT, Lambda, voice services, to create a new experience, connect it even to virtual worlds, and glue these things together. Now, the next thing you're going to tell me is, Ollie, that's very nice. lots of fun, but I'm not going to go back to my boss and tell him, we need a robot for my company so I can play around. But use case is also very popular in the industrial space, connecting or overlaying a real world with something virtual, very often called augmented reality. What you see here is a video that is recorded from a Microsoft HoloLens, and that HoloLens is actually using a piece of software from PTC ThingWorks, which has a thing mark, which you see here. And that software is used to overlay IoT sensor information, temperature, fuel engine, or the electricity, etc. It also has a CAD model of the engine itself, so it can render a 3D overlay onto my smart glasses. And what it allows me now to do is give instructions how to perform maintenance of that machine. Here it is an air filter that we need to take out. So connecting a physical world, building an interface for my customer or my user to actually give instructions. This is how you repair it. If you repair it successfully, good. If not, I immediately see it was wrong. The IoT sensor data will show me that it didn't work. So connecting things together allow for new business models, allow for complete new solutions. An open ecosystem allow for broadly integrated solution. Here we use the HoloLens in combination with ThingWorks, in combination with IoT services. If we build a solution, we need to take the right things and bring them together. I want to give you an example. What you see here is a generic OBD Bluetooth connector. OBD stands for Onboard Diagnostics. It's a standard developed for cars, and it was developed for car mechanics to plug themselves into the car, read out information of the engine, the sensors, etc., to make a decision what they need to repair. It was roughly established most cars after 1997 only have OBD. Traditionally, that meant taking a cable, plugging in, looking what's going on. If you have a Bluetooth connector like this, you can actually read out this information through your smartphone. So I can see in real time the information that my car is sending me. That's cool. But what am I going to do with it? Well, there are companies like, for example, Dash. Their URL is dash.by. Dash builds an application, a smartphone application. If you install it, it can connect to that OBD Bluetooth connector. And now it can analyze your data that your car is sending in real time and provide diagnostics. So, for example, it gives you a driving score to gamify the experience how you drive. Do you drive efficient, or do you drive very inefficient? Do you drive your car and you see the red traffic light and you slowly roll over? Or do you go all the way to the top and then jam your brakes? It's not very efficient. So this score allows us to get a good understanding. But more importantly, if we get into a crash, these sensor information, like an airbag trigger, etc., they will all give us indications if it was a serious crash, and if it was a serious crash, we can immediately notify the emergency services. How do we know the position? This thing got GPS. So we can basically tell them, in this position there was a crash. But here's the really powerful thing. Based on the data that they're collecting from all their users, they build machine learning models around that data. A lot of people drive the same car than you might drive. So you can learn what are the normal values from the sensors from that car. And when there's an outlier, then I can use that to potentially detect a breakdown of the vehicle, detect the potential breakdown of one of the components in your engine. And if that happens, Dash will send you a notification. They'll say, this part of your car break down. By the way, here's a list of 10 car mechanics just next to you that can fix it. And by the way, this is how much it's going to cost me. This is the repair cost for this component. That is a great user experience. But more importantly, Dash, they did not build the car. They did not invent OBD. They didn't even build the OBD Bluetooth connector. They just developed an application that taps onto an open ecosystem of existing standards and platforms. And as developers, we want to think about how we can integrate into that. Now, the other part here is machine learning. Machine learning is becoming an increasingly important part to deliver a solution. What do I mean with that? Well, traditionally, if we thought about machine learning or data analytics, we think data warehouse. One big data warehouse, stuff all the data in, and then run a query, information out of that data. We continue to have more and more data points, very fast, lots of volume. We call it big data. The data warehouse does not scale for big data. I can make it bigger and bigger, yeah, but that's also going to be more money, more expensive. So if I just keep growing that, it's not going to be efficient. So one trend is to say, I decouple compute from storage. I store my data on something like Amazon S3, where I only pay for storage. And only when I want to get information out of that data, I pay for the compute to process it. And this is such a common pattern. A lot of our customers use things like Spark or Hadoop clusters to query data from S3. Bring up the Hadoop cluster, run through something, shut it down, stop paying for it. So popular that a lot of our customers have asked us, can you make that easier for me? So we have services like Amazon Athena. Amazon Athena allows you to run an SQL query on your S3 bucket, on the data that you store there. CSV files, XML, doesn't matter. Packet files. And you get the results back. And you only pay for the amount of data processed. No server, no node, no cluster, nothing. All of that taken care of. So analytics is also becoming increasingly serverless. For us as developers, what does that mean? You want to build a data lake on a cost-efficient storage. My recommendation, Amazon S3. From there, we have services that nicely integrate for machine learning, Hadoop clusters, SQL queries with Athena, business intelligence, BI tools, all very easy to now process that data without moving or loading it up. For me as developer, that means I need to build the integrations for my application straight into the data lake. Don't be the developer that says, this is the data scientist's responsibility. No. Your responsibility to get the data in. The data scientist will analyze the data. It's also your responsibility as a developer to help with the transformation of that data, to get it into the shape that data scientists can use it to build cool tools. And I say serverless for analytics. I want to give you one example. There's a cool open source project. It's called Pyron. And Pyron allows us to run Python code from our laptop, push it to the AWS cloud, use AWS Lambda to process data massively parallel across thousands of Lambda functions, do the calculations, and then bring the results back to me. Because most data analytics jobs can be run in parallel. Take that one data point, process it, give an output. Take these 1,000 data points, process them, give the output. Sequentially? No. Parallel. That's what I want. This project allows any data scientists which generally use Python to now not even change their code, just use the open source project, crunch to massive amounts of data. Parallelism is extremely powerful. If you take an example like here, where we run 2,800 Lambda functions at the same time, you can reach up to 40 teraflops. You can reach up to 80 gigabytes per second throughput on an Amazon S3 bucket. That's really fast performance to do transformation. And guess what? You only pay for the execution time of the processing job. That's very powerful. Adjust the mic a little bit, it comes off sometimes. Which brings me to the point of how does that evolve for us as developers? Openness, understanding businesses, machine learning. Traditionally, as a developer, we wanted to do certain things, but they are changing. We want our product or our service to interact naturally with us. Use voice, use computer vision, right? Use my phone to recognize the face. Samsung had that long before Apple, didn't they? But also have systems that are artificially intelligent, that understand what I'm doing, get better as they are learning. And also personalize the experience, right? I want my product or my service to know who I am. And my users will expect that individuality. For me as a developer, that means the following. Traditionally, I know computer science. I know computer science, I can develop code, people are hiring me. Then it changed, and they said, yeah, developing is good, but you also got to understand the business. If you understand the business and you're good in computer science and you're in space there, then you're very valuable for the business. With the increase of machine learning, with the increase of AI, we will add a third pillar to this, which is a good understanding of mathematics, a good understanding of statistics and statistical models. And if you bring that to the table, if you're in that magic quadrant there, then you're very useful for your company. You have extreme value for your company because you can bridge all the important elements that you require to make a successful product. But it also means for us as developers, if we are not good in those areas, we will struggle. We will struggle moving forward to have good and interesting products, services, and jobs that we're building. Within Amazon, we actually recognize that. We take our software development engineers, SDEs, and we retrain them to be machine learning engineers. And I encourage you, if you're a developer like myself, have a look at machine learning in general. Have a look at some of these statistical models. Because the more you know, the better you can build applications out of it. Now, with that in mind, we don't want to code patterns anymore. We don't want to look at the data, try to identify what's going on, and then write an algorithm for it. We want our system to learn from the data itself. We want our system to learn through the data, which is pretty much the pillar of artificial intelligence. Learn from the data, improve from. And one of the key drivers of artificial intelligence is the recent advancements in deep learning, which are specific ways of structuring neural networks with multiple layers to build a more intelligent system. What do I mean with deep learning? I want to give you one example, and an example that is easy to visualize. So we want to build a system that not only can do tasks that normally require intelligence, but we also want that system to be able to adapt to us human beings. So let's take an example here. You know what this is? This is a Rubik's Cube, very popular toy in the 80s. This is a 3x3 Rubik's Cube. I had one. I never managed to solve one. And I was very frustrated. You know, I felt really stupid because I go to YouTube and you have this guy, he blindfolds himself, he takes the Rubik's Cube, 5 seconds later he fixes the Rubik's Cube. How did he do that? How did he do that? Right? And you get really frustrated. You're like, am I that stupid? Sit there for hours and hours and I can't fix the Rubik's Cube. 4 seconds, Christ. Then I decided, okay, how about looking at all the possible combinations that a Rubik's Cube has? Maybe that will make me feel better. And it did. Because if you look at the Rubik's Cube, 3x3, it has 43 quintillion possible unique variations of combinations on how we can shuffle it down. That's a lot of combinations. So I felt a bit better. But that guy on YouTube, he still manages to solve that in a few seconds. Why? Because there are patterns, recurring patterns. And if you know those patterns, you can solve the cube without going through all the combinations. So if I write a piece of software, a computer program, an algorithm that solves a Rubik cube, I have two choices. The first one, I do backtracking. Try every possible combination until you find the solution. Worst case, I need to try every 43 quintillion possible combinations. Does it work? Yes. Is it very inefficient? Yes. So my second option is, I want to understand the pattern. And if I know the pattern, I can write an algorithm for the pattern, and then I can solve it quickly. That is what deep learning is. But deep learning is about the ability to say, I take a combination where I know how to solve it, and then in between, I put a machine learning model, a deep learning function. Put that in, this is the output, shove it in the function. Function will learn, all right. Gets a certain accuracy. I bring the same cube, it knows how to solve it. I bring a different one, not quite. So what I'm going to do is, I'm going to take another Rubik's Cube combination where I know how to solve it, feed it through the model, accuracy goes up. Next thing I'm going to do is, I'm going to say I take another, maybe 100 combinations, where I know how to solve it, I feed that to the model, and now the learning function will learn and it will improve the accuracy. So that when I take another unknown combination, it can now predict with that accuracy, based on the patterns that I learn, this is possibly how to solve it. And variations out of 43 quintillion is really not that much. So that's efficient. And obviously then I can have some fun, right? I can build a machine. I can put some cameras on it. I can put some actuators on it. And then I can solve every Rubik's Cube in 0.9 seconds. Take that, YouTube guy. There you go. So I can have fun with it. The power of deep learning is that we don't need to know the pattern to use the pattern. We learn through the data. And obviously solving a Rubik's Cube is a problem that has been well established and very well solved. But take this as an idea around what deep learning can enable you to do. Take your data to learn the pattern. And that brings me to the point that data is the first thing that you need when you build machine learning models. Sometimes I talk to some of my customers and they're new to machine learning and they say, I want machine learning. Here, these services, you can do that. Do you have data? No. But I want machine learning. It doesn't work that way. We got to have data to actually train models. And again, for us developers, if you do machine learning, great, right? You're already doing that, perfect. Don't keep doing that. But what if you don't? Start with thinking about all the data points that you can collect. Collect them. Put them in Amazon S3. Cost effective. And then when you decide I want to build models, well, then you can use that data to train your model. Positive and negative reinforcements. Similar to how human beings are learning, right? How am I able to walk? Well, when I was a baby, I tried to stand up, I fall. Okay, that hurts. Negative reinforcement. Try one more time, fall again. Ouch, not good. Right, I lean a bit back, now I start learning. The same way these deep learning models work. You give them positive, negative reinforcements, and they adjust itself to find a pattern. Out comes a model. From that model, I can now start making predictions. I can infer from the model. Sometimes people stop here. They build a model, they infer, done. Not a good idea. Your first model is never good. Your first model is the first iteration. And from that, you need to learn. How to learn? You put feedback back. I make a prediction. I make a prediction the customer will buy this product. Did he buy it? Positive reinforcement. Did he not buy it? Negative feedback back. Get better. And now you create a loop where you feedback, you train the model with the new feedback, you get a new model, you infer, you get feedback. Cycle. And now you are increasing the accuracy of your model. You're learning, and your system gets better and better over time with the help of your customer, with the help of your users. And then I can build really cool things. And at the foundation of this, if we want to build deep learning machine models, there are frameworks out there that are really easy to use. Tensorflow, project by Google. MXNet, project that has been jointly developed with the open source community in Amazon. Caffe and Caffe2, project by Facebook and Amazon jointly. Microsoft Cognitive Toolkit by Microsoft. Torch, Keras. All of these frameworks are great frameworks to build your machine learning models, to build deep learning models, to build artificial intelligence. We make them available to what we call the AWS Deep Learning AMI, Amazon Machine Image. With a click of a button, you get access to all of these frameworks installed with all the correct drivers, with all the right dependencies, with all the right libraries to get started. And by the way, don't underestimate that libraries are very important. If you take the Intel MKL, which is the math kernel library, if you try to make prediction on images with or without the math kernel library, it's about 100 times faster. 100 times on the same hardware. All right, so having the right libraries makes a big difference. And we worked with Intel. Intel is a partner. We work with Intel together to optimize these things. Now, what can I do with that? I can do cool things. I can build computer vision models. What you see here is a project by a company called Too Simple, which is a customer of AWS. And they want to build autonomous vehicles, self-driving cars. And they use lots of image and video material, train a model, and then they run it on this car here. And it allows you to infer from it. If you can read Chinese characters, actually it tells you even the brand. This is a Volkswagen right here. Recognizes the cars, recognizes the people, recognizes the tricycles, the motorcycles on the street. And that allows me to now provide assisted driving or of course, fully autonomous, self-driving cars. There's a challenge here. TuSimple, this company, is using AWS to train these models, bring up large clusters, shovel all the data in, learn from it. They have a model, and that model can be used for inference. Well, do I want to run that model on the cloud? I could, right? I could run this model on the cloud. But what if it's a self-driving car? What if the internet disconnects? I stop the car, I just run into the person and be like, boom, I didn't recognize him. Probably not a good idea. So that model runs on the car itself. The prediction is done on the car. The training is done in the cloud. So what I want you to think about is, what do I do in my cloud environment? Training a machine learning model, storing your data, all good. That's where it belongs. And we work with companies like Nvidia, for example, which produces GPUs. And they just recently announced the Tesla V100 unit. Gives you up to 120 teraflops on a single unit. That's powerful. Whoa. That's powerful. So powerful, the microphone falls off. There you go. And we are now making that available to the EC2 service. The EC2 service, as of a few days ago, charges you only per second that you run it. So I get access to powerful hardware like this and only pay for the amounts of seconds that I use it. Build up large clusters, train the model true. Now I have the model, then I can use services like Greengrass or AWS IoT, push the model out, run the inference, only send back the relevant information and synchronize it back. And there's also a piece of hardware like Jetson TX2, which is the new card that Nvidia has launched. Credit card size shape, this small. Powerful GPU, can do real-time object detection of a video stream. And I mentioned earlier, we always take security as of utmost importance. If you wonder what this is Amazon's tool that requires me to update my laptop. So what I want you to think about is what belongs into training the cloud, what belongs at the edge, and where can Amazon help with the services to make it easy to move it to the edge, and obviously with the training. And some of the inference also belongs into the cloud. If I make a prediction on a website, if a customer is likely to buy, then the website runs in my cloud, so I run the model in the cloud. Now, if you don't want to train your own model, you say, okay, TensorFlow, MaxNet, all cool, but I don't want to learn that. That is where you can make use of fully managed services that we provide, that use deep learning under the hood, services like Amazon Poly or Lex, which are services that allows you to build conversational engines, have a system respond to you in different voices that sound natural. Lex, by the way, is based on the technology that the Alexa voice services are using. Alexa, what's inside? Lex. That's where the name comes from. Or services like recognition, which allows you to identify objects, identify scenes, identify people, recognize their faces, recognize if it's a celebrity, recognize if it's the same person, see if that person is happy, if he's sad, etc. The key point here is all of these services are just a web service away, an API call away. One API call, and I get access to a pre-trained deep learning model that we continuously improve. So can I have some fun with that? Of course. Remember my robot? How about we build something cool cool with that robot, beyond just controlling a virtual world? What if I make my robot identify objects and then go and find those objects right here on stage? I call it the banana finder, because I'm going to train my robot to actually find a banana. If you follow the machine learning space, there are a few fun projects out there. Another one that I can recommend you is a project called Hot Dog, Not Hot Dog, that recognizes if it's a hot dog or not a hot dog. Great little projects to learn how some of these things work. So what I'm going to try to do is, I brought actually some cans of Coca-Cola with me, right? I brought some bananas with me. What I'm going to do is, I'm going to put them right here on the stage. And the next thing that I want to do is, I want to have the ability to actually show the same object to my laptop camera, and I then want the robot to go and seek out the object on the stage. And I want you to look carefully, because later you're probably going to ask me, how did you do that? And it's very simple, but I want you to have a look at it closely. So Andy, I also invite you back up on stage for this, so you can help me with it. So what I'm going to make use of is a service called Amazon Recognition. And Amazon Recognition allows me to identify certain objects and faces and so on. And it's an API call away. So what I'm going to do is, I created a little local website here. Here's the HTML code. And I'm going to make use of my webcam. And with that webcam, I'm going to snap pictures pretty much every 900 milliseconds. I'm then going to go and send those pictures to the recognition service. All right? And I will try to detect the objects, the labels in here. And if I find certain objects that I'm looking for, like Coca-Cola or banana, I'm going to tell my robot that he should go and search for the object that we want to notify him about. Okay. Want to explain this quickly?
간단히 한번 또 설명을 드릴게요. 아까 AI 서비스라고 해서 아마존에서는 폴리, 그다음에 레코니션, 그다음에 렉스라는 서비스가 있습니다. 근데 지금 보여드릴 데모는 그 중에서 이제 레코니션이라고 해서 이미지를 레코니션 서비스에게 보내게 되면은 그 이미지에 있는 여러 가지 아이템들을 찾아서 알려주는 서비스가 있어요. 그래서 레코니션한테 캡처된 이미지를 전송을 하면 얘가 바나나인지 아니면 코카콜라인지 찾아서 응답을 주게 되면 아까 설명드렸던 것처럼 여기는 랩탑하고 여기는 라즈베리 파이는 아마존 웹 서비스의 IoT 서비스에 연결이 돼 있어요. 그럼 두 개가 메시지를 주고받을 수 있기 때문에 그 라즈베리 파이는 바나나나 코카콜라 나타나게 되면은 역시 이 스페로우 로봇을 컨트롤해가지고 움직이는 것을 데모로 보여드리겠습니다.
So if I enable first the recognition here, it will now take these snapshots from my browser. My browser will send it to recognition, and you see that it now starts recognizing things. People, person, human, self, portrait. Sounds about right. The next thing that I need is, I'm going to power up my robot here. Just calibrating him. Duke. Is he going to come up?
Hello.
There we go. All right. All right, that's okay. I'm going to put the robot here on stage. Now we can switch to the camera on the screen. I can just put the perfect, thank you very much. And now what I want to do is, I will use recognition. I'm going to show this object to the camera, and if it detects obviously what it is, it will try and go and find it. There you go. Found a banana. Let's try that out one more time. Let's see if that wasn't a fluke. Let's have a cook. There you go. Go back to the Coca-Cola. Go back to the banana. There you go. There you go. And we find the object. A fantastic way. And if we look at some of the output that's going to come through, we now connected these things together. And if you look at the JSON output here, you see that we told the robot to go search that object and then roll to the position of where that object is sitting.
보신 것처럼 바나나랑 그 다음에 코카콜라를 레코니션 서비스가 딕테이트하면 텍스트를 돌려주죠. 그러면 거기서 IoT 서비스로 메시지를 보냅니다. 그러면은 여기서 라즈베리 파이가 그 메시지를 읽자마자 역시 블루투스를 통해 가지고 로봇의 좌표를 바꿔주는 거죠. 좌표 값을 바꿔줘서 그 위치로 로봇이 움직이는 것을 보실 수가 있습니다.
Thank you, Vinny. I love my job. I get to play with robots and bananas and Coca-Colas, and isn't it wonderful? But I want to leave you with a few things. This is just a demonstration. It's my way of having some fun and highlighting some concepts and how we can get access to really cool things with just an API call away. What that means for us as developers, as we build services and products, let's have a look at how we can integrate things, how we can use connected devices and be open around it, like the Alexa voice services. I control a robot. I use a Raspberry Pi, control the robot, change things around. Use a gaming engine like Yacht, which is free and open for me to use, and build a final solution. Think about that example of the Bluetooth OBD connector, right? Open solutions, making it possible for you to build successful products. But more importantly, think about how machine learning and AI can help you to create new interactions with your customers. Right now, using our voice is still new. We only start to use it. There's Alexa voice services, great, it's working, but it's still in the early stage. But our users will expect that to be normal. You know, I have a small nephew I have an old computer at home, and last time he ran towards it and he touched the screen, he's like, it's not working. I was like, it's not a touch screen. You got to use a mouse for it. They grow up where touchscreen is totally normal. I predict that computer vision and the ability to talk to a device is going to be the next normal thing to do. AI and ML is powering this. I'm not saying it will replace. I still want my keyboard. I'm not going to program and develop using Alexa. That's not going to be fun. But it will complement how we interact with our customers, our users, smart glasses, etc. So think about how you can make use of AWS services to make that journey a little bit more easier. And with that, I want to say, it's never been a better time to experiment, try things out, build some demos, learn from it, look at the services that are available that make your life easier, and experiment around. Thank you very much for your attention for that.